So I'm excited about this new unit. We're going to be talking about electricity and electronics. And then we're going to learn how to build electrical circuits. And ultimately we'll get to the point where we're integrating our circuits with a microcontroller or mini computer. You know, we've talked about capacitors, we talked about resistors or transistors, but we really haven't gained an understanding of what those things actually are. So we're going to spend some time today trying to get some definitions in place. Okay, so this is pretty basic. I know a lot of this you've certainly covered in physics, but I'm just trying to set the foundation for the rest of the stuff we're trying to learn. From science class, you know, there's matter, there's elements, and there are atoms. How do they relate to each other? Well, kind of elementary definition of matter is something that has mass and takes up space. Matter is made up of elements like gold and oxygen. You learned that in chemistry class as well. And elements are made up of atoms. So when we talk about electricity, we have to figure out, well, what is electricity? What is its actual nature? What is it made up of? And to do that, we have to talk about these basic things. So if you look at the structure of an atom, you'll note that there's a nucleus. So what's inside the nucleus? There's two things. There's a positively charged particle known as a proton. And then there's also neutral particles called neutrons. And then surrounding the nucleus, there are negatively charged particles in various orbits called electrons. When we talk about electronics, we're talking about electrons moving through a wire. I don't see anyone taking notes, but you probably should be at this point, because these slides aren't going to be online, so you do really need to take notes. So let's go back to that first slide then. We'll write this stuff down. So anytime you see a word that's in bold and italicized in my slides, that's a word that you need to know the definition of. And it's crucial to the understanding of the stuff that's coming later in the presentation. So the three definitions here: matter is something that has mass and takes up space. Matter is made of elements like gold and oxygen, and elements are made up of atoms. Now, can you make antimatter? The opposite of matter. You know, antimatter, if it meets up with normal matter, they both annihilate each other and they cease to exist. Can you actually make antimatter? You can actually. If you take two gold atoms and smash them into each other at high speeds, you create antimatter. And they've been able to keep the antimatter from interacting with anything else by using a magnetic field that holds it in place so it doesn't actually interact with any matter. The big question scientists have right now is, well, why is there so much matter and so little antimatter? If you look at current subatomic particle theory, I guess, they don't have an understanding of why that is. It should be about the same, yeah.
Did they say if antimatter actually got out, it could destroy the whole universe?
No. I mean, you'd have to have an equal amount of antimatter. Yeah, it destroys the whole universe. There's the experiments they're doing in CERN, the CERN laboratory in Switzerland, where there's this possibility, perhaps, as they're colliding subatomic particles, it would make a small black hole and then suck in the Earth. But the percentage of that happening is pretty small, so I think we're safe. If you suddenly feel the urge to travel to Switzerland, you'll know. Now you'll know why. Yeah, scientists don't have a clue on why there's hardly any antimatter, because you look at all the math equations and it should be about 50-50, right? But that's not the way it is. Okay, again, here the structure of the atom, you know, and we've seen this in lots of different science classes, but you have a nucleus. Nucleus has two parts, neutrons and protons. The protons are positively charged. The neutrons are neutral, and the electrons are negatively charged, and that's what holds the whole atom together. Now, we were talking about quantum computers the other day, and they just completed an experiment where they quantumly entangle two subatomic particles and separate them. I think they're electrons. Separate them by about 1 kilometer, and they change one and it changes the other. And there's no way they could possibly communicate. So how is that possible? Quantum mechanics. It starts getting really weird. So yeah, you can change the state of an electron that's 1 kilometer away by changing the state of this electron if they're quantumly entangled, whatever that means. But it takes basically your whole idea of physics and throws it on its head. Einstein hated what do they call it? Standard model, I guess. To him, it didn't make any sense at all. He saw order, and all he sees in the standard model is this, I don't get quantum mechanics. He did not like it. He spent the last 15 years of his life trying to make some sense of it. He wasn't able to do it. It's taken scientists from around the world to even get a basic understanding of quantum mechanics. Pretty soon you're going to see some amazing things, though, being created because of their understanding they're getting down at CERN. You live in a really interesting time when it comes to science. Okay, so what are we talking about when we talk about electronics? So electronics is a part of physics that studies the movement of electrons through a conductor, typically a wire. We're looking at the flow of electrons. That's what electricity is. It's a flow. It's electrons moving through a wire. So that's what electronics are. It's just all about electrons. We don't care so much about the neutrons or the protons. It's electrons. It's our focus in electronics. And my father is an electronic engineer. He's had quite an interesting life. So my dad has always had an electronics lab in our house. And that was strange. You go in, there's all these oscilloscopes and weird stuff. It's like a secret laboratory. Then electronic engineering is an engineering discipline focused on creating useful circuits that control the flow of electric current. The machines sitting in front of you certainly are probably the pinnacle of electronic engineering, creating computers that can play games or take notes or any of that. All that comes from electronics. Now, my dad didn't really grow up in the age of solid-state electronics. He grew up when there was vacuum tubes. The first computer was all vacuum tubes. All right, so in our experiments that we're going to be doing, we're going to be using a battery. And because of that, I want to talk a little bit about the structure of a battery and how a battery works. How do the electrons flow through the battery? Well, we all know that batteries have a plus and a minus terminal. One's the cathode, one's the anode. That's the formal names. And usually they're made of two different elements. Typical batteries are made of zinc and carbon, but sometimes copper. You know, they talk about the copper top battery. There's actually no copper in that battery. And then they're separated by a chemical, I think they call it an electrolyte, and allows the electrically charged atoms to move through that membrane. So for example, in this picture, I think it's some kind of saline solution that allows the electrons to flow through different sides of the battery. You've seen batteries blow up, right? They blow up and then there's this acid residue that's left. Okay, so there's a force between the two terminals of the battery. That force is called voltage. Okay? Voltage is the force that I always look at kind of like a pump. You know, if you take the water analogy when it comes to electricity, it's really handy to try to understand it. So you could look at voltage as water pressure. Water pressure being pushed through a pipe. That's voltage. Voltage causes the electron flow from the negative terminal to the positive terminal if a path is created between these two terminals. I always thought it went the other way, but voltage goes from negative to positive. So if you connect those two, the positive to the negative end, then voltage will flow through that wire or that circuit. Now remember, I was playing golf over at Heron Lakes Country Club, and I was in the men's washroom, and this guy took his ring out of his pocket, and it was burning hot. He dropped it on the counter, and I didn't even know this guy. He goes, "My ring is like burning hot. What would cause that?" So I'm thinking, do you have a 9-volt battery in your pocket? And he takes it out and it's melted. There's your problem. And then he said, "Well, how did you know that?" That's about all I could think of would make it do that, though. So if you connect the two terminals on a 9-volt battery and it just feeds into itself, it melts the battery. Don't want to do that. So this flow of electron defines the term electric current. How important are batteries? Well, certainly you take a look at our handheld devices. They have batteries that can last all day. Some of the earlier battery technologies had problems. When I was your age, the rechargeable batteries were made out of nickel cadmium. They had a problem though, because the chemical they had inside would crystallize at certain levels. So unless you completely drained the battery and then recharged it, it had this memory where it only would hold about half of its charge than when it was new. So I had to design a system that would completely discharge the battery and then recharge it overnight, so that when the handheld computers go out the next day, they have a full charge instead of dying halfway through the route. My solution was pretty simple. You just put an LED on the battery and let the LED bleed off the power until it gets down below a certain level, and then switch it over to recharge it. So a simple solution to a difficult problem. After NiCad, there were nickel metal hydride. The newer ones are lithium-ion batteries. What do they use in cars? You know, I'm not quite sure, but I don't remember either. I should know that. But in electric cars, what's really holding everybody back is our battery technologies are pretty terrible still. If you want to, create electric cars, it takes a long time to charge. All right. As we learn about electronics and electronic circuits, we're going to be learning the schematic symbols for each of the components. So I'd like you to draw this into your notebook if you can. This is the symbol for a battery. Kind of odd looking. But if you ever read a schematic about maybe a piece of electronic equipment you have, you'll see this perhaps symbol included in the documentation. And you need to be able to recognize these symbols, because we're going to be making circuits where all you get is these symbols, and you have to figure out which symbol it belongs to or what component it belongs to. But this is the one for a battery. So who created some of the world's first batteries? Yeah. Yeah, clay pots way back when. More recently, Benjamin Franklin made one. Didn't provide a very consistent voltage flow, so it wasn't very practical, but he was able to create them and show them. He did a lot of experiments in electricity. So.